Hello, Precal class. Hopefully, you guys are having a good time and having fun and getting ready for all these super awesome semester exams coming at you. All right, guys, this is a continuation of Note 17. We're going to go more advanced. We're going to get more in detail with trig identities. And we've already covered this trig identities, guys. Cosine squared plus sine squared equals 1. We call it the Valentine's formula. Of course, that's not the real name, so don't go to a professor and say, oh, yeah, the Valentine's formula. It's called the Pythagorean trig identity. And so we can write cosine squared plus sine squared equals 1, and you can rewrite it as sine squared equals 1 minus cosine squared, and that's easiest done by just, so I'm going to show you here, guys. It's easily done by just writing that cosine squared to the right-hand side. So you can see that if you do that, you have sine squared equals 1 minus cosine squared. And doing the same thing, you can also isolate the sine squared or the cosine squared by moving the sine squared to the right. So that's what we have here. So from the Valentine's formula, you have these two equations, and they're pretty much the same thing. You can interchange them as needed whenever you do need them. So whenever you see a sine squared, recognize that you can replace sine squared with 1 minus cosine squared. Wherever you see a cosine squared, recognize that you can replace or substitute it with 1 minus sine squared. Now, don't just substitute it for the sake of substituting it. Substitute those expressions whenever you feel that they will help you. Now, remember, 1 minus cosine squared, guys, is the difference of squares, so you can always factor this out into 1 plus cosine x, 1 minus cosine x. And then remember that 1 minus sine squared is also the difference of squares, and you can always factor that out with 1 plus sine x, 1 minus sine x. Sorry about that. All right, so that's pretty much all you got to know about those. And then, of course, I wrote here 1 plus tan squared equals secant squared. Guys, this does not just magically appear out of thin air. If you take the cosine squared plus sine squared equals 1, and you divide everything by, let's see, if you divide everything by cosine squared, cosine squared over cosine squared, that's a 1. Sine over cosine, that's a tan, but notice that both of the terms are being squared, so that's going to be a tan squared. And then 1 over cosine, that's a secant, but notice that the bottom is being squared, so it's going to be a secant squared. So there it is. That's where it comes from. This guy, 1 plus tan squared equals secant squared. And then we just rewrote it. What did they do? They just move the tan squared to the right to get 1 equals secant squared minus tan squared. So whenever you get the expression secant squared minus tan squared, if you feel that it helps, you can substitute it with a 1. And if you ever see the expression secant squared minus 1, that's the same thing as tan squared. If you feel that it helps, you can move the 1 to the right, and you can see that you get tan squared by itself. All right, using the same logic, I don't know why it zooms in like that when I just do. All right, using that same logic, guys, we have that cotangent squared plus 1 equals cosecant squared. Again, that comes from dividing your Valentine's formula all by sine squared. And again, you get cotangent squared plus 1 equals cosecant squared. So there it is, guys. Check mark. I guess that's not a very good check mark, but it doesn't matter. And then, to isolate the 1, you can see the 1 right here. You can just move the cotangent squared to the right. So it becomes cosecant squared minus cotangent squared. Or if you want to get the cotangent squared by itself, you just move the 1 to the right. So it becomes cosecant squared minus 1. So look at all the different equations we have just from that. All right. And then it says, which is the even function, which is an odd function, and why does this matter? It's not necessarily talking about these, like the Pythagorean identities, what is even, what is odd. What it's talking about is what sine, cosine, and tangent, which one's odd, which one's even, which one, does it even matter? So which one's odd, which one's even? Well, hopefully you remember that an even function has this characteristic. And if we don't remember that, all it means is symmetric about the y-axis, guys. Cosine happens to have this. It's symmetric about the y-axis. So, cosine, if you have a negative angle, that's the same thing as a positive angle. And that's why when you do the inverse of cosine, you have a plus minus in the front, because cosine of pi over 6 is square root of 3 over 2, but cosine of negative pi over 6 is also square root of 3 over 2. Let's see. If cosine is even, that means the reciprocal is also even, guys. So the reciprocal of cosine is secant. So secant of negative theta has to also equal secant of theta. All right, now let's talk about odd. So an odd An odd looks something like that. So I tried to, of course, my graphs are not perfect. Odd function has this characteristic. By the way, this is even. I guess I didn't write it. So an odd function has this characteristic. F of negative x equals negative f of x. So in algebra 2, we called it symmetric about the origin. You can also say flip, flip. I wouldn't necessarily call it flip, flip, but some have in the past. So if you rotate this or flip this about the origin here, if you rotate quadrant 1 about the green line here, or the y-axis, it'll be in quadrant 2. And then if you flip it again on the x-axis, what you have in quadrant 2 will now be in quadrant 3. So that's what it means, flip, flip. As you can see that it works. Quadrant 1, if you do a flip, flip, it'll be in quadrant 3. And I'm not sure if flip, flip is necessarily a mathematical term. Symmetric about the origin is probably the best. So here we go, guys. So notice the characteristic here. So if I have sine of negative a, that is the same thing. And by the way, this is like saying a right there and negative a there. That's the same thing as saying negative sine of a. Or, I guess we could go back to thetas. Sine of negative theta is a negative sine theta. And it makes sense. It makes sense. Travis, how does this make sense? Well, think about if theta is pi over 6. If theta is pi over 6, we know that sine of pi over 6 is a half. So look, I have this here. So sine of negative pi over 6, is it the same thing as negative sine of pi over 6? Well, let's see. This in brackets, that's just a half, because pi over 6 is right there. And now notice I'm circling it and I'm putting it in blue. That's a negative pi over 6. So negative pi over 6 is right here. And sure enough, that y value, the x value is the same, but the y value here is the negative half. And I'm trying to write as best as I can, guys. And then notice we have a negative here in the front. So the output of this would be negative half. Good job. It works. It works, guys. So there it is. Now, if sine is odd, that means also its reciprocals are odd. So what's the reciprocal of sine? Cosecant. So I'm going to write it right here, guys. Cosecant of negative theta is equivalent to negative cosecant of theta. All right, now we just got one more. We've already covered cosine, sine, secant, cosecant. Now we have tangent. So tangent. Is tangent odd or even, or it may be neither, right? So tangent, so let's see. Let's just observe. If I were to tell you what is tangent at pi over 4, you're going to tell me, let's see, what are you going to tell me? You're going to tell me 1. If I tell you what is tangent of negative pi over 4, you're going to tell me negative 1. So because it looks like it has this characteristic, looks like it has that characteristic. So tangent is odd, guys. And I probably should have made more room, guys. My apologies here. Tangent is an odd function. If you graph it, you will see that it is symmetric about the origin, or quote-unquote flip-flip. So tangent's an odd function, so that means that it also applies to the reciprocal of tangent, which is cotangent. So there it is. We covered all the even and odd for sine, cosine, tangent, and there's reciprocals. So yay. And then it says, what about when sine, cosine, tangent are squared? Well, if you're squaring, guys, then this whole odd even thing goes away. Only if you're squaring, because when you square something, you're going to have a positive output anyways. So for even function, it doesn't matter, but it matters more so for odd functions. So let's see. Here's what I'm trying to say. Does sine of negative pi over 6, and this whole thing squared, does that equal the same thing as sine of pi over 6? And that squared. Yes, it does. Let me tell you why. Because sine of negative pi over 6 and sine of pi over 6, even though they are opposite signs, they have the same magnitude. And when you take any number that is the same magnitude and you square it, it's going to turn into a positive and it's going to be the same value. I hope that made sense. I'll say it again. When you take a number and it's negative, and you take the same number but positive, so it's the same magnitude, like let's do, for example, negative 3. When I square negative 3 squared is 9. When I square a positive 3 squared is 9. So you can see it doesn't matter that it's negative, because when I square it, it's going to be back to positive. So sine of negative pi over 6 in this case, let's see, that's going to be, and I'm sorry that I changed the color there. That's going to be a negative half, and when I square it, I get a positive 1/4. All right, let's do this here on this side over here. Sine of pi over 6 is a half, and when I square it, I get a 1/4. Notice 1/4 equals 1/4. Yes, they're the same. So it doesn't matter. So what I'm trying to say, Chavez, what are you trying to say? Give us a statement, please. What I'm trying to say is this, guys. Sine squared of negative theta is equivalent to sine squared of theta. And that's going to be true for all of them. All of them. For cosine, it doesn't matter. It wasn't an even function anyways. Tan squared of negative theta is the same as tan squared of theta. All of them. Even for the reciprocals, guys. All right. What identity should you know cold? For sure, you should always know cosine squared plus sine squared equals 1. You should know, guys, that cosine and sine repeat every 2 pi. So you should know that cosine theta plus 2 pi is the same thing as cosine theta. It's the same thing for sine. Sine of theta plus 2 pi is the same thing as sine theta. What else should you know cold? Tangent repeats every pi, guys. So tangent of theta plus pi is the same thing as tangent theta. Chavez, I don't understand. Why? Tangent of pi over 4 is 1. Tangent of 5 pi over 4 is also 1. Notice there's a linear line right here. From here to here, that distance is pi. So that's why tangent theta plus pi is the same as tan theta. This also works for all their reciprocals, guys. So you should know that. So there it is. And then for sure, know this one cold, like cold. And I think we've covered all our bases, guys. Know that cosine and sine differ by a phase shift of pi over 2. So what does that mean? That if you take your cosine graph and you shift it by pi over 2, it's going to look like sine. Same thing by sine, guys. If you take your sine graph and you shift it by pi over 2, it's going to look like cosine. So because of that, we have this identity, or I guess it's not really an identity, this property. Cosine pi over 2 minus theta is equal to sine theta. And then you can say the same thing for sine. Sine of pi over 2 minus theta is equal to cosine theta. And if you don't believe me, guys, let's go to Desmos real quick. I mean, I know you guys believe me, but just in case. Where is Desmos? Desmos. Graphing calculator. And I'm going to type in here y equals functions cosine pi over 2 minus x. And look, you can see that's exactly sine, guys. If I type in y equals sine, see, it's the same graph. If I get rid of this cosine and I type in sine, and I go function sine, and let me get rid of that extra parenthesis, and you can see the red line looks like cosine, and it is. Watch, I'm going to turn sine here into cosine. And there it is, guys. It's the same graph. That's because they only differ by pi over 2. So if you shift one way pi over 2 in a specific direction, it'll look like, see, if you take this blue curve and you move it pi over 2 to the right, if you take this point and move it pi over 2 to the right, all these points, it's going to look like sine curve. So, yay. Okay, I'm glad we understand it. I mean, I hope we understand it. I can't answer questions right now because you're watching a video. You're not, like, live. Okay. Yeah, someone's judging me. They looked at me and they're judging. So, don't judge, miss. Okay, here we go. Next question. So, yeah, I think we're good here. I think we got it. I think we're ready. I think we're ready, guys, to tackle these questions. All right, so when you take your quiz, let's see, I think it's called And this is going to be 25% of your semester exam. Did I say 25% or did I say 50%? Oh, man. I think I said 25. Oh, yeah, I said 25% because this is just one topic of the many. All right, so when you take your quiz, it's going to be 25% of your semester exam, guys. This is the quiz that you're going to take. And here we go. These are the type of questions that come out in there. So the first thing I notice is that besides one answer choice, all the other answer choices have a positive argument. So what I'm going to do is I'm going to get positive arguments because only one answer choice has a negative argument. So remember that sine is an odd function, so I'll put a little negative on the outside, and there it is. And remember that cosine is an even function, so I just changed the negative to a positive. If you don't know what I'm talking about this, guys, about odd and even. So I'm talking about this specifically. Cosine negative theta is just cosine theta. And then I'm talking about this specifically. Sine of negative theta is just negative sine theta. So that's what I did. And now notice I have sine over cosine. Well, sine over cosine is just tangent, guys. So negative tan theta. And I look for that. And there it is. All right, guys, let's go to the next one. All right, on this one, it says, which of the following is equivalent to cosine squared over 1 plus sine theta? And I have these four answer choices. And immediately I see something is being squared. And I say, can I substitute something for that? Well, yeah, you can. If you go all back to the page 1, you can see from this equation right here that I'm circling in green, cosine squared is equal to 1 minus sine squared. So I come back and I'm going to write, okay, I'm going to substitute what cosine squared is. It's 1 minus sine squared. So I'm going to write 1 minus sine squared over 1 plus sine theta. And then from here, you're like, okay, now I'm stuck. No, you're not, guys. Remember that 1 minus sine squared, that's the difference of squares. So I can rewrite this as 1 plus sine theta, 1 minus sine theta, all over 1 plus sine theta. And now you're going to notice that I have a factor that I can cancel out. I have 1 plus sine theta on the top. I have 1 plus sine theta on the bottom. And you can cancel those out, and you're left with 1 minus sine theta. Yay, another one, guys. We did it. All right, this one looks hard. Relax. It's not even that bad. So it says, which of the following is equivalent? And they try to trick you. They put x plus 2 pi and then x plus 2 pi. But remember, sine and cosine, if they have just an x like this one does, if you add 2 pi, you're going to have the same value. Cosine's going to have the same value because the period of cosine, the period of sine is 2 pi. So I'm going to rewrite. So cosine x over sine x plus sine x over cosine x. Remember, guys, all I did, guys, in case you're wondering, I just did this. Remember, cosine theta plus 2 pi, sine theta plus 2 pi. And really, it could keep going forever and ever. Cosine theta plus 4 pi, 6 pi, 8 pi, as long as it's as long as it keeps adding, as long as it's the multiple of 2 pi. All right, so now I have this. Now what? Well, I guess the next best thing is to find a common denominator. So I'm going to multiply this one by sine over sine. I'm going to multiply this one by cosine over cosine. So when I do that, here's what you're going to get. Cosine squared x over, I guess I'm going to write it as sine x cosine x. Or cosine x sine x. Cosine x sine x plus sine squared x over cosine x sine x. Alright, same common denominators. I can group them together. Cosine squared plus sine squared all over cosine x sine x. Hopefully you remember your Valentine's formula. Cosine squared plus sine squared, that's just 1. And I can rewrite this, guys, as 1 over cosine x sine x. And now that I have it written like that, I can rewrite this as 1 over cosine x times 1 over sine x. 1 over cosine x, that's just secant x. And then 1 over sine x, that's cosecant x. And there it is, guys. Another one. All right. Nothing crazy there. Pause it if you feel that I'm going too fast, guys. All right, here's question 4. This one's probably the toughest one so far. What happened? It just zoomed out in there. And I think there's our last one. Yeah, that's the last one. All right, so the first thing I would do, guys, I'm going to isolate this part. I just want to see if I can reduce that. I have a cubed on the bottom, so I'm going to write 1 plus sine theta. And that cubed, I'm going to write it as cosine squared theta times cosine theta. So I'm just going to see if there's a pattern here, if there's something I can factor out. And, I see a 1 minus sine theta on this term, and I see a 1 plus sine theta. So I'm thinking I may be able to do something with that 1 minus sine or 1 plus sine. So I'm going to take this cosine squared, and I'm going to replace it. What am I going to replace it with? If you go all the way to page 1, I'm going to replace the cosine squared with 1 minus sine squared. So here we go, 1 plus sine theta over, and I'm replacing cosine squared with 1 minus sine squared theta. And now that I have that, I see a 1 plus sine theta on the top, and I realize, hey, the 1 minus sine squared, that's the difference of squares. So I'm going to write 1 plus sine theta. And on the bottom, I'm going to write 1 plus sine theta, 1 minus sine theta. And I still have that cosine theta here on the side. So notice, I have a 1 plus sine theta on the top. I have a 1 plus sine theta on the bottom. Those cancel out. Now I just have 1 minus sine theta cosine theta. So I'm going to write that part right here. All right, so now I'm ready. So now I'm going to write whatever I have left. Now, rewrite. I'm going to put the secant theta over 1 minus sine theta. Secant theta over 1 minus sine theta. Minus this guy. 1 over 1 minus sine theta. Cosine theta. So at first glance, you're probably thinking, oh, I'm going to do common denominator. And you're right, you should. But notice you have a secant theta right here. Secant theta is nothing more than 1 over cosine theta. It's the reciprocal of cosine. So if I rewrite again, actually no equal sign because it's a brand new one. Now it's equal sign. If I rewrite again, I can rewrite this as 1 over 1 minus sine theta cosine theta. This right here, that right there, that is secant theta, guys. And that I'm subtracting 1 over 1 minus sine theta cosine theta. So hopefully all that makes sense to you guys, I hope. And you'll recognize that I'm just taking 1 over 1 minus sine theta cosine theta, and I'm subtracting, again, the same shebang, the same thing. So if I'm subtracting the same thing, then that means this is, yeah, you're right, 0. I mean, I didn't actually hear you guys. I'm assuming you said 0, or you whispered 0, or you mouthed 0, like, oh yeah, 0. But yeah, there it is, guys. So hopefully that made sense. That was the last question. See if you guys can tackle, and of course, don't expect perfection the first time, guys. If you have questions, please come to tutoring. I'm going to have tutoring this week, Wednesday, Thursday, and for the first time ever, well, not ever, but for the first time this semester, we're going to have an official tutoring on Friday. So try to solve solving trig equations. No, not that one. Trig identities. Number 1. And if you have questions if you don't know how to answer some of them and you try to answer as much as you can, come to tutoring. I'll have tutoring from 4 to as late as it takes, guys. 4 to 5 at least, but if we have a good crowd, we'll keep going. So, all right, guys. So that's it. I hope I hope you wrote good notes and upload your notes for an easy 100, and that will be the last grade of this 9 weeks. All right. Talk to you guys later. Bye.